Yeah, hi everyone. So we'll start the session basically. Okay.
Good evening, everyone. So it's my pleasure to introduce Biswajit Satapathy, a senior AI engineer at Ozonetel Systems. He specializes in speech and language technologies, including automatic speech recognition and natural language understanding. With prior experience at IIT Kharagpur and Yatna Software Private Limited, he has a strong background in speech analysis and software development. He is passionate about exploring AI advancements and encourages his team to continually innovate and learn. Please join me in welcoming Biswajit Satapathy. Thank you.
Yeah, hi everyone. Thanks all for joining and thanks for like having me here. So hope you all are like doing good. So with this, let's like come up our like the session basically. So we will today. I think before you like must have like came across l- uh, in like previous class there like what exactly is AI and how ML is related to AI and stuff. So like this class will try to see how natural language processing it works basically and what is a language model, okay, and how to approach like how to build a like language model basically, okay. So with that, I would just share my screen. So hope you all could see my screen basically. So like first of all actually let's you know see actually what exactly is language model, okay. So before knowing language model, what is language is like something basically what we use for any like kind of communication, okay. So when we are like talking about here like language model or LLM is large language model. Like why it is large? Because we are using huge amount of data and a huge like amount of weights and parameters to train it. So because of that, it is known as large language model. But prior to that, here LM actually it is nothing but we are building everything on text. Okay. Later point you will come across like multimodal where you will be having text like audio, video, or like images. That's it, like like different things to deal with and there will be different approaches to that, but like for now we'll be discussing what exactly is language modeling on text, okay. So already I think you have got an introduction on what is embedding and like what is tokenizer. So still I'll just try to you know try to brief on that, and I'll try to like our this class approach would be we'll try to like understand how tokenizer like what exactly is tokenizer, how it is built, and how optimally we can choose a library which can help you to build a tokenizer from scratch, and how much data we need to train that. So like roughly we'll just discuss about this, okay. Like proceeding for tokenization, okay. So let me tell you first what is tokenizer. So in earlier technology like nowadays we use like neural networks to like prior to this we have been using like many techniques called bag of words and everything. We were just using words as one on token. What is token? It's a basic unit that can be processed by like computer basically, okay. Again, what is why we need to define best like basic units, because that is what we're like here, like when we talk about like LM, basically we are nothing but doing classification. Okay, what exactly we are classifying is a token or a basic unit. Okay, so that can be word, that can be a character, or it can be a part of word also. Okay, so because of that, I just it can have, three way of tokenization is possible, but everything, like all three approaches have its like has its like pros and cons. Okay, but mostly use these things, tokenizer is subword tokenizer. Why it is like mostly used? That's for one reason. It is more flexible towards outer vocabulary, and it is rich in like morphological like representation. What is morphology again? If you talk about language, right? In for a particular like language, particular piece of text, they have some meaning and rules, right? So those rules are known as actually morphology in like very high level. Okay, so it is related to the meaning. Okay, so like so nowadays you like must be using chat gpt, llama, then like like gemini and everything. So these are nothing but large language models. Okay, and all these models, they use actually subword tokenization. Though we'll go through all the tokenization, how they have built and everything, but specifically we'll try to learn more on the subword tokenization only. Okay, so let me yeah, so go through first. So like before we proceed further, I just want to make the what exactly we are trying to achieve at the end of the day. So because this tokenizer is just a part of whole roadmap, basically this is just a very initial stage where like where you will learn how do I represent a word in a space, right? So or like a text, a, a like piece of text in a space, basically. Okay, that is where it starts with. But then how do we reprocess them, how do we prepare the data, how do we put them into like model training, and how do we test it, all that thing we'll be discussing, like going forward. But for now we will be focusing on only tokenization. Though let me give you a you know uh, roadmap, basically. Okay, so what all like whatever the language you use these days. Okay, like like whatever the like language model you use these days, they actually they are based upon one single like mathematical tool. It's called attention. Okay, so you can just go through this and see like what exactly attention is, and maybe we'll take a chance to explore this like about this more. But uh, like right now I'll just give you a brief introduction to this, so that you will have an idea what exactly we are going to do. Okay, so now attention is something basically which try to attain word with like in like by means of like representation of by means of relationship with other words in same text or other text, basically. For an example, let's say the text is the teacher the teacher taught the student with a book. Okay, so now with in this text actually, if you look at the relations, right, what teacher is doing is he is teaching, right? So taught is nothing but a form of teach, right? And now the same way, to whom he is teaching is student. Okay, and who is getting taught? The student. How he is getting taught? No, like by means of book. So as you can see, the highlighted part are actually uh, they are most prominent actually relations. Okay, so let's take an example. One more example. Ram is sitting on the chair. Okay, now you tell me, if I remove is on the, still my like meaning of whole text might not change. So those are actually most important words which which carries information, right? So because of that, their weights are more. So these weights are learnt by the mechanism. It's called self attention. Okay, so now whatever the language model we built actually on top of this architecture, and with some encoding of techniques basically. Okay, so there are three different ways of modeling, that is encoder only, encoder decoder, and decoder only models basically. But nowadays mostly used is decoder only models. If you take GPT, then llama, then like like uh, Gemma, then Anthropic, whatever, most of the models you see actually they are based upon decoder only architecture. Okay, so these are just I have just noted down some of the architectural details. Okay, so to train a language model, we go through three different stages. One is pre-training, one is supervised hunting or instruction tuning, and reinforcement learning. So in this session of our class, we will be more focusing on pre-training part of it rather than going for supervised fine tuning or reinforcement learning. Okay, so to train any language model, basically what we need, basic need is uh, you know uh, text or data, and the text should be huge text, and they they should not like those texts should not have errors. If you have a lot of errors in your text, then that is going, those pattern also they will be learned by language model. Okay, and at the same time, if you look at security perspective and some other things, your language models your 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 language models should not be biased towards particular uh, article, particular. So if it is biased means it is going to perform good for that, and for other tasks it will not do good actually. At the same time, if it has hate speech and all, it is going to mislead people and stuff. So all that precautions we must take when we are thinking of pre-training a model. Okay, so I have just taken some stories. Okay, you might have uh, children's stories. So here I have some children's stories with me. I have uh, so these are actually very small stories, for 3 to 5 years kid. Okay, just 5 to 6 sentences hardly they have. For example, let's look at quickly one story. It's called like Storian like society. We are at a like community. So now you see, it is like describing a unlike a social entity. Okay. Same way, I have something about what is money. So when you try to teach a small kid between 3 to 5 years, basically, you will be like usually in the book, it will be like written about like money, its importance, and how do you take care, where do invest, all that thing with a very simple language. So all these things, I have a data for now, which you can just start with. Okay. So before we go for a complex uh, you know uh, tokenization, let's try to like understand what exactly tokenization is. Okay. So here I have written like for you a basic like tokenizer. One is character tokenizer, one is what tokenizer. So why made in such a way that it is easy to understand if you're a beginner. Okay. But in real time, you if you use this one, the speed and everything, we need to like optimize, and the, like there are other things to be like considered. We will discuss that later point. Okay. So here I'm just using a library called string, okay, which has all the ASCII characters, and it's a basic Python program only, which will give you insight about how tokenization works. Okay. And here, as you can see, I have used some of the keywords, that is vocab size and decode. Okay, these are the basic things you will be going to use, like you'll be using these words again and again in your whole journey of creating a language model. Okay. So what is vocab sizes? Vocab stands for vocabulary. Okay, what is vocabulary? It is the list of tokens you have got with you. That is nothing but the vocabulary. Okay, those are basic tokens, and you will be representing all text given to you with a vocabulary set. Okay. So here for character tokenizer, I have defined like characters as vocabulary. What are the like characters I have like considered is ASCII, digits, then different type of like punctuations. Like apart from this, whatever else is there, I'll not consider them as my like in my vocabulary. Okay. And at the same time, so here the consideration is this the character tokenizer is built for English language only. If you need to have Hindi or like Odia, like any other language, you need to have their own like character set. Maybe you like you can start try like UTF-8. Okay. So like same way, I have done word tokenizer also. So how words are uh, like handled, basically, given a piece of text, if we chop by like white spaces, right? Those are every like unit will be word. For example, for an instance, let's say we have same sentence, Ram is sitting on the desk. Okay. So now every word is is like separated by a space or like white space, right? So these are nothing but my word separators. Okay. That's the reason here I have used actually space as word separator. Okay. So let's run it quickly and see how it works. Okay. So now, as you can see, using tokenization, it generates actually every one on token. Okay, here even white space is a token also. But if we go through what tokenizer, okay, so here what I've done is actually for character tokenizer, I had to define what are the characters I want to consider. But when I came for word tokenizer, right, here game is different. How it is different? Because I need to have valid words to train, right? So what are the valid words? How do I know? So here what I do is I need to have a text set. Right now, as I showed you, this is my text set. Okay. In real time to like build an like model, basically it can be in million example will be there. Okay. But this is a demo system where you will be using this to learn. So I have just taken the like this one for an example. Okay. So to build the okay. So now after building this one, let's try to see how many vocabularies we have got. We have vocabularies of okay. So that means I have 1292 words. Okay. If I want to check that out also, I should able to check that out. See, I have word to ID is actually every word I have assigned one or a number to them. This number will be used to transform our word to numbers. Okay. So let's try to encode and decode. Okay. So like what is encode and like what is the process where we are trying to get tokens. So basically from I should able to get the words. Okay. And decode is if I have tokens, I need to transform back to text. So that process is known as decoding. Okay. So your whole let's draw a flow how a like decodes basically. Okay. So first it starts with let me put this. Okay. So input is text, right? So input like given input is text. Okay. Then we get token from token. So token we are obtaining in the means of tokenizer. Okay. Or you can say ZDR. Okay. So whatever we get actually from token, we pass it to we encode them like we embed them actually embed them, then we interpret them, then we infer them. Don't worry about the words, I will go through each and everything one by one. Okay. Then we are doing decoding. Okay. At last we have text again. Okay. So this model is known as text to text like model basically. Okay, because we are giving as text, it is understanding is so when it is trying to interpret basically. Okay, so it is trying to like being spoken and all that context, and based upon that it is generating some other text. That is how any LLM works. Okay. Said to you ki these are actually basic tokenizers, right? Huh. So here actually, as you can see, I have SL token, right? Okay, so I think hope this is clear to everyone. Yeah. All this code actually I'll be sharing with you guys. You can go through this and you can like get back also later, no issue. Okay. So as you can see here, I gave here actually RAM is sitting on the desk, but we got actually many unknowns apart from is, on, the. Apart from this, everything else is UNK. Why? UNK here is a special type of token which represents unknown. If any word is out of vocabulary, means that word is not there in our vocabulary, that is known as out of vocabulary or unknown token. Okay, so this is a disadvantage of word only token, like word tokenizer. Basically, if you don't have like sufficient amount of text word, then it is going to create problem for you while training or in like while like like inferencing, if we have some new words which is not there in vocabulary. Okay, so that is the reason actually most of the like system these days they prefer subword tokenization. Obviously, you may ask if why use like characters. So let's have a logic around it. Okay, if you look at character, the number high for any character, if you look at the sequence length is too high. It is like, see, for this small piece of text I have 26. So let's pick one. Do We'll just go to Wikipedia. Let's pick some text. Okay, let's say I will just search artificial intelligence. Okay, let's pick this text and we'll try to tokenize. Okay, this is a small like paragraph basically, and we'll try to tokenize this. So let me encode this character token in text, right? So let's look at how many tokens it has got. Sorry. You can see this small piece of text itself, it has 408 tokens. Okay, so just keep this in like mind basically. Whenever your number of token or you increases, basically your sequence length increases. If your sequence length increases, then the like computation goes so high. Okay, so we will need more powerful like, computer, and at the same time we will need more data. So like whenever we are going to train any large language model, we need our data size will be proportional to how many classes we have. That is like nothing but your vocab, you know, your like vocab size, and what is your maximum length you are trying to process at a time. That is nothing but context window. Okay, So these two are actually main factor which plays a big role in text generation. Okay, so let's try to see exactly same thing for using word tokenizer. See, word tokenizer it is only 60, but let's try to see how many are valid words, because I have not used it here actually, many words basically. So let's try to see what are the things we got. See, hardly maximum are actually unknown. Only some of them I got actually. Only some of them I got. Uh, what you say? Yeah. So like some of them only I got. Most of them they're actually unknown only. Okay. Now you see only is a of in science that. See here, most important word, if I go here, most important word is artificial intelligence, because I was searching for artificial intelligence, right? And what is intelligence? What is machine? All these are very much important words, but that is missing over here because we have a very constrained. So let's try to see how we can, prepare a bigger and robust, like word tokenizer or word tokenizer. Let's look at actually first word piece tokenizer, how we can build a word piece tokenizer. So here I'm using actually one library called tokenizer. Okay, so this library is implemented using Rust originally, so which is much faster. Okay, and it is very, like lightweight to process data basically. So you like handle actually huge amount of data, and with like better system it does in seconds actually you can uh, like generate actually a tokenizer. And just key either it is sentence piece or like word piece tokenizer. Before we used to like consider all the words over here, but here we can define what is the maximum, vocabulary size it can be if it is a sentence piece tokenizer. And for word piece, it depends upon again, the like number of words. And don't worry about this now, these symbols I will explain it. Let's try to build first. Okay, so as as you can see, there also I was using unknown. Here also I'm using unknown as an unknown token. Okay, apart from that I have some of the like special tokens which are going to decorate my you know like data for well, like language body like learning basically. So let me, yeah, and don't worry about whatever I'm doing. I'll be passing run through this and check it out. So I'm just taking the same text like whatever I have shown you. So why here double N basically, because I know for me every like story basically it is like separated by two new lines. Okay, so this can be much more like complex to divide going forward. So this can be part of data preparation itself. As this is a very simplistic example, I know or I could split them out. Okay, does basically it will iterate over all data. So now let's try to see what is text, what text contains. Sorry. So I have all my, you know stories over here, right? So let's try to learn the pattern. So here, when I'm trying, like when I say learning like pattern means, here we are trying to see which word has how much frequency. Based upon that, we'll sort them out, and based upon that, we'll put importance to them and keep them in vocabulary. Okay. So I have already trained just by like running this. I have trained it. I have that less, but still I have how much of data? Let's look at 1200, whatever the amount is there, right? So with this, let's see how much time it takes, right? 8 milliseconds. Okay, let's try to compare. I'm just curious. I didn't try this before. Let me try this out with this basic. How much it took time? Let me just quickly try it out. Okay, so that you can have a comparison. So let's put it here. Time. See here, 4.89 millisecond because this is small amount of data. But if data grows like million and billion, obviously this is going to increase exponentially. This is 5 milliseconds, but here, as you can see, it took 8 to 9, 8 to like 9 milliseconds. But if the text grows, trust on me, actually, for this is going to be huge time saver. Okay, so now already created a tokenizer successfully, and I can have its IDs also. Okay, and even let's, if you want to try same text over here also, and try to see what is happening, right? So let me put this aside. See here, let's, here we'll have still, here we have 71 tokens. Okay, because we have some like special tokens also here, but here we had how much? 60 tokens. Here we have 10 tokens more. Okay, because in what is the difference between, like between what tokenizer and what this tokenizer is? If I have like ing, I am going go ing, so this will be two pieces. Okay, so this way we can just created a directory to save my like model basically. Okay, so I'm just saving this. So I, as you can see, let's look at this now. Okay, let's look at this, what this contains. You can see this contains nothing but, my bad, this contains nothing but actually like word and their identities only. Okay, you can just go through this and see like what exactly is happening and how it is happening, right? So same way, as you can see here, even if you look at my the vocabulary I gave it, like I showed you here, right? This has also the same thing, exactly same kind of thing, but this is a simpler model. This is nothing but same, like same only, right? So okay, now let's look at how, like what is the vocab size over here. Here 43. Here, see the difference between this tokenizer and that tokenizer is Here we had 1200 plus, I think, vocab size, right? Let's check it out. Sorry, here our vocab size was 2500. I think we just ran twice, because of that it has taken that, but it would be 1200 around. Okay, let's check it out again. Yeah, this is 1200 like 92 basically. Okay, so now as you can see here, right, this is a better system, right? This is representing same text with less number of tokens. Okay, so now you don't worry about these things, but still just keep this in mind, that this is being trained. Like if you want to train a like language model, we will be using a a library called like Hugging Face. Okay, Hugging Face transformers. Okay, Hugging Face transformers. So this library we will be using. Okay, so to make use of this library, we have some of the format actually, that's called Hugging Face format, and the tokenizer format also, it is Hugging Face tokenizer format only. So we are just storing in that way, but exactly same actually. Okay, so here the text, like whatever I had, I can just put them in a like Hugging Face datasets, and I can just dump them in a, let's say, Word datasets. Okay, I'll store them this. Okay, so this is my data is actually prepared for pre-processing for training, right? You can just check this out, what it contains. So it has a arrow file basically, which is nothing but a like a tabular representation of data and its information and state. Okay, so the same way, let's try to build a tokenizer which is called sentence piece tokenizer. So what is like how here it is the these things. This technology is based upon uh, subword tokenization. Okay, so take actually whole word, rather it will try to look at a part of word which is repeating in a whole context, or and how they are like behaving in like within a like sentence or text. Based upon that, the you know like frequency of each word is being like computed, and based preparing the tokenizer. Okay, so let's get started. Same way, the I'm using actually same library. Okay, as you can see, I'm using same library, but here I have just tried to. So let's keep a vocabulary size of let's keep it 500. Okay, so that it will keep only 500 these things. For now, reserve token I have kept 256. So let us keep at least. Let's remove this and let's keep only. Don't worry about this actually. Okay, I'll keep 25 right now. So I'll have 500 total as vocal size. Okay. So again, same way, I'm just defining my post processor and stuff. You don't worry about this for now. Okay. And this also here we are doing the training basically. Okay. And if I want to check out what is the time it is taken to train the system, you can always go ahead and check that out, verify here. Okay. Sorry. My bad. Takes 68 milliseconds. Why 68 like milliseconds? Because here when you are doing word piece tokenization, that time you are just looking at less number of tokens basically, but here it is looking at more number of tokens. So it is obvious that it will take a bit more time than this, and it so this actually sits in between your like character model as well as like like I mean word based tokenizer and character based tokenizer basically. Okay, so just to give an example, you can just check it out. Let's say llama 3 tokenizer we have. Okay, you can just go ahead and check out meta like llama and whatever the like tokenizer they have. Let me go through llama 3 8 billion. Okay, so here if you go through, no, this is nothing but your tokenizer only. Okay, this is a very large file, so it is not able to open, but if you just click on raw and you want to see, so we are actually as you can see, like whatever I have shown before, we are I'm generating something like similar to this only. Okay, so yeah, so let's so we have done this one. Let me save this model. Okay, so here also same way we'll be storing them in a in like Hugging Face tokenizer format, so that we can later point figure that out, like check it out. And same way I can the way uh, I had used like WordPress tokenization to yeah the way I had used WordPress tokenizer to tokenize the data and store it for pre-processing. Here also I can do the same thing. Mm, my God. Okay. So let me copy this step to here and save same way. But by doing this, you can check out your data. The size will differ based upon the tokenization basically. Okay, here I didn't read the data actually. Okay, this part I'll just add this and share with you guys. So what we have learned here actually, how to do a tokenization given a text like a like bunch of text or huge text. So this strategy it might vary when you are using actually a billion text or million text based upon your like how much RAM like you have got and everything, right? Uh, yeah. So this is all about how do we prepare for to like build a tokenizer and how you can prepare data after building, right? So the same way, uh, like let's try to like understand a bit. I think we are nearly out of time right now, but give me just 5 minutes. Just allow me that time. Actually, I'll try to what exactly we have used here. Some of the tokens, right? What exactly are these used for, right? So as I have shown you before, okay, in my slide, we use a technique called attention mechanism, right? So like let's consider my attention has some of the words which has more repetitions in the context. Okay, so that means those word those words will have more emphasis, like those words will have more strong attentions, right? So think like every word like in your text you have full stop nearly how many like sentences are there, that many times are there, right? So importance of like full stop at sentence end will be much higher, right? So the same way here, as we are dealing with a free text where it can be a like paragraph, a question and answer, it can be anything else, right? So because of that, there is a role of special tokens. So what exactly is special token? Let's take an example of llama 3. Okay, Let's take an example of Llama 3. Right? Yeah. So as you can see, yeah. So one second. So this library always gives you actually, like, here there are the collection of, okay, Llama tokenizer. Yeah. This library is a collection of whatever the transformer based, these things are there, like models are there. They have all the collections basically. Okay. Let's try to read through what they have got, right? So what they are trying to say is the Llama 3, it is trained on, okay, I think I missed the reference. Yeah. So like Llama 3 is a BP based model basically. So I, as you can see, whatever we have done also, it is a BP based. This like sentence based tokenizer, it's a BP based tokenizer only. Okay. So we have tried to imitate Llama 3 like model only. Okay. Let's say I'm trying to write a story, right? Let's take this example. Okay. Let's take two of this to give an example how it can be represented. Okay. So yeah, let me put it here only for your better understanding. Let me zoom out a bit because I'm not able to control the things. Yeah. So let me put it here. So now let's say I can decorate this something like this. Beginning of text, when text begins actually. Okay. That is beginning of text. Okay. And when text ends, that is end of text. Okay. Let's say I'm just breaking these things. Let's say this is end of text. Okay. But now what if if I want to give an instruction. Okay. So let's say, so I'll have again a text, beginning of text and end of text also. Okay. Okay. And then I'll have so one header which will represent what exactly I'm trying to do. Okay. Let's say system. Okay. So this is a hierarchy I'm trying to create basically. Okay. Whenever system means I'm trying to define some rules. So I'm just writing the rule is you are a helpful assistant which will help me learn AI. Okay. This is what actually exactly I'm trying to like command to system, and system is going to give me output is based upon my sorry based upon my question. So here I will have a question. I'll just copy the same thing. I'll change the role. Role is user. User is asking, okay, what is AI? Okay. Then system is going to answer artificial intelligence, blah, 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 blah. Okay. So this is nothing but it's a representation what you need to prepare for a like information, when you want to do fine tuning. Okay. So now hope you have got some idea about how like the importance of. So now because these texts actually they are occurring again and again, so the transformer is going to learn the pattern that whenever I have said a start of header, okay, it is nothing but actually it is trying to learn. And yeah, I have mistakenly missed something, that is I must have headers here also. This is assistant. Okay. Yeah. And I can have obviously this EOT is end of text. Okay. So I can put end of text here. I can put end of text here based upon wherever I want to like, like put a gap basically. Okay. So now let's look at this. As you can see, you are chatting with a chatbot and you asked, you are like, first you are actually defining. Yeah. First you are defining what is the behavior of bot it should be. And then you are asking the question. Then it is going to answer in this way, right? So this is, if we keep in this way, we will able to parse what exactly I have asked and what exactly bot said, and so on and so forth, like so far basically. So this is how. So this is the like, contribution of special token basically. If you don't use special token, you can't have like control on your generation. So to have more like control over your generation basically, we use special tokens. Okay. So like going forward, we'll learn more about how to prepare data and how we are going to do pre-training. Okay. Or how we are going to fine tuning basically. Okay. So for today, I just wanted to begin with how in detailed tokenization works. Hope it could help you to uh, like get like introduction. Okay. So now you are open to ask any question if you have any.